Hi! Today on Periodic Perfection, I'm going to be spilling all the chemist tea on how to use Table J to determine if your redox reactions happen. Let's get straight into it. Here's our reaction. We have aluminum reacting with zinc. Now, to determine if this is going to happen, first thing we need to do is look and decide what's free state. Our aluminum has no charge with it, neither does our zinc, which means both of those elements are free state or completely unbonded. Now that we know our aluminum and our zinc are free state, we're going to take a look at our reactant side of the equation. And we're going to see, is our free state element higher on table J than our ionic substance? So we want to make sure that our item that is free state is higher. So this is our free state. Free state needs to be higher, and our ionic substance needs to be lower. So let's take a look at that and see if they are. So our aluminum is our free state, and right there, there's our aluminum, okay? And then we are going to look for our zinc, and our zinc is right there. So our free state element is higher than our ionic element, and that means we are good to go. So let's go back to our previous page and we're going to work out this redox reaction. We said that the aluminum is 0. Then we're going to look and decide whether we have oxidation or reduction happening here. Oops. Our aluminum is going from 0 to +3. That means if we're becoming 3 more positives, that we have to be losing 3 negatives. If we are losing, that is oxidation. We are losing 3 electrons because we're going from 0 to +3. We're going to look at our zinc situation. Our zinc is going from +2 to 0. That means we must be gaining electrons. And in this case, we are gaining 2 electrons to go to our zinc in free state. Now we've got a little problem. We know that our electrons are always supposed to balance out to be the same number. And now we've got 3 electrons being released from the aluminum and 2 electrons being gained by the zinc, and that just doesn't work out. Well, what can we do? We can go in and multiply either of our lines or both of them by a number, it doesn't need to be the same number, to balance out our number of electrons. So if we look at our oxidation, this 3 gives me a big clue. What can I multiply this 3 by? What can I multiply this 2 by to give me the same number? Well, 2 and 3 can both be multiplied by another integer to get 6. We could multiply everything in the aluminum line by 2, which would make this 3 a 6, and that would get us a 6. We could multiply everything in the zinc line by 3, and that would get us our 6, and we are good. What do we do with that information now? We bring these coefficients up into our original equation. So our 2's, I'm going to make that look more like a 2. Use a curly 2. Our 2's go in front of the aluminums, and then we're going to bring our coefficients from our zincs up into their position. We've got a 3 and a 3. I don't know why that one's red. Smartboard doesn't like me. We all know it. It's a conspiracy. Okay, so now we have written out our reactions. They're balanced. We've determined if the reaction happens. We're all good. We're going to do another example here. And we're going to look at this reaction. Will free state gold, we know it's free state because the charge is 0. It's not shown in this case. Our spectator ions have been removed for us already. React with our nickel +2 ion. So our free state is gold. Our ion is nickel. We need gold to be higher. We need nickel to be lower. Let's look and see if that's the case. So we're going to find our gold. Gold is all the way down here at the bottom. Nickel is right here. So we needed our gold to be higher. That means this reaction is not going to happen. We come back here. We won't be doing any work to show this being balanced because we can't, because this reaction doesn't happen because the nickel is more reactive than the gold, which means the gold is not strong enough to kick our nickel out of this reaction. There you go. Thank you very much.